Hello, everybody, and welcome to the next OpenValue meetup. My name is Mauro Palsgraaf. I'm software engineer at OpenValue, and I will be the host of this evening. Due to the lockdown, we cannot record from the studio, but we try our best to make this meetup go as smooth as possible. We will start today with a presentation from Kevin, who's going to talk about visual recognition with machine learning. We will follow this up with a 15 minutes break to give everybody time to get a drink. And afterwards, we will go to Roy Braam, software developer of JPoint and founder of OpenValue Amsterdam. He will present about end-to-end testing environments. Important, if you have any questions during the meetup, you can type them down in the chat so I can ask them afterwards to the presenter so that you will get your answers. Without further ado, let's give the stage to Kevin for the first talk.
Thank you, Maro. Hi, I'm Kevin Berendsen. I'm going to be doing my talk about JSR-381, visual recognition using machine learning. I'm also a software engineer at OpenValue, but also part of the expert group about this talk. So furthermore about machine learning. Machine learning is really recognizing patterns in data and making predictions against that data. So to give you an example, you can make a machine learning model that is able to recognize patterns in photos of cats or dogs, for example, and is able to make predictions based on new input data that you give it to. For businesses, for enterprises, it's slightly different or more or less the same. Basically, applied machine learning is in enterprises is to maximize ethical business benefit based on those predictions. So use those predictions to make business decisions really. So when you want to create a machine learning application, more or less, you can do that as long as you use Python, right? Python is a very popular language. Thinking about TensorFlow um, from Google, but we are Java developers, right? So the majority of the viewers here as well are Java developers, and we're not alone. I mean, there are 12 million of us. So it's kind of weird that we don't use Java for machine learning applications, even when we want to. So already answering actually this question, why are we building GSR 381? First of all, we think that Java needs to be a first-class citizen for machine learning. So it needs to be equivalent or near as good as Python is. And the reason why is that we don't want JavaScript doomsday scenario happening again. As well as everyone knows now is that JavaScript is really popular for web-based applications, and it's pretty much the only choice that you have to be doing that. And we don't want um, to allow Python to end up like that. So that machine learning can only be achieved via Python or another language called R. And I think that Python is a very good language. I've tried it myself. I've used it from time to time myself. But I think that, and my colleagues as well, think that machine learning should be widely available across other languages as well that you are very comfortable using. For me, that would be Java. And Java is a really great language. As a user ecosystems of 12 million developers, it also allows more machine learning applications to be built if you only know Java and when you don't know that much about machine learning. Same for me. So what's the GSR going to offer? It's a standardized Java-friendly API for visual recognition. So we'll be focusing on visual recognition tasks specifically. It contains a generic machine learning API. However, we will definitely be focusing on the visual recognition part, but the generic part for machine learning is one of the things that we think that's also very necessary to embed within this API. And from the start, from the get-go, there are already multiple implementations available to choose from. You will be able to choose from the reference implementation, which is the default implementation that you can pick. It's pure Java, by the way. And then you can also choose another implementation that will allow you to use Apache MXNet or TensorFlow, for example. And we built this API on a high level abstraction. So you don't need to know a lot about machine learning. Actually, you need know a lot less about machine learning than you would think of using this API compared to other APIs. So we started while we started building the API, we also started talking to companies, to very large companies actually. And when we talked with them, we always asked them the questions, why not Java, right? Why don't you use Java for machine learning? And they always came with, well, the APIs are not really not that great. The features um, that are built in Python are much more widely available than on other languages. So we started just learning Python and started using technology written in Python to accomplish those, to build those machine learning applications. And they were all very interested in what we were doing, and some of them already collaborating with us to make this API better. To give you an example, AWS from Amazon Web Services, is already working with us on integrating with our API, at least with implementing our API using uh, their own libraries that they own, and that also allows other users from who are previously using TensorFlow also to be using those models in Java and using a very simple API. So we think that's really great. So the solution is really, we need to promote Java for ML, and we need to start somewhere, and that's why we also picked facial recognition, because it's um, very visualized. So it's not just numbers and other mathematics that's applied, and then eventually there's a number that as output. Now we pick something that you can actually see, and that's much more convenient when you start learning building machine learning applications. So our API goals and architecture, the design goals and principles that we have, we need to enable Java developers to use machine learning using the Java skills. I mean, we've been doing Java for so long, why not use it for machine learning, right? And also it should be able to be used by non-experts in machine learning. I'm not an expert in machine learning either. Um, but once I've joined this group, I've come across a lot of experts that taught me on how to do machine learning, right? And what's and how easy it is to understand with an easy API, and that's currently not really provided, especially not in Java. And actually, I had to learn Python for it. So, and it should also, the API should also be easy to implement by existing machine learning libraries. And that's also something already we have proven about by allowing Amazon to implement our API. So what can you do with it? There are two main tasks, but the second task is somewhat part of the uh, uh, third task. So first, we're gonna allow users to classify images and data objects. So that's pretty much a classification task. And that allows you to either say an input image, uh, in this case, it's a penguin, or it could be a rabbit, right? So you train that model to be able to classify the input, whether the input is a rabbit or a penguin. And the second task would be to estimate value, which is a regression task. So that's something that we won't, which is not necessarily linked to a facial recognition, but it's definitely a part of um, the third option, which is object detection. So that's a very popular one when you're thinking about facial recognition. Is what you would usually see when you would Google for facial recognition, for example, that it detects objects in a certain image or video stream. It's able to locate objects and then classify it. So it's using regression to calculate a potential position of an object, and then classification happens over that position, was also called a bounding box. And then if it returns a certain threshold, it will return um, whether it's classified or not. But we will primarily be focusing now, also in this talk, on classifications. So like I already mentioned, is that we got classifications here. We know as humans that um, this is a puppy on the right side and on the left side it's a kitten, right? But a computer doesn't know, and a computer only sees bytes. So we need to make the machine understand that on the left side is a kitten and on the right side a puppy. We also call this, because we are only talking about two classes, we're talking about binary classification. So there are only two classes. When we talk about one more, it's we talk about multi-class classification. And also the binaries, uh, the name itself already says that it's binary, just it's a 0 or a 1. So either one of the two. When we go a step further, we got the object detection, which, like I said, is able to detect the position of a possible object and is able to classify that position. We got two kittens here, a rubber duck, or I don't know whether they classify this as duck at the bottom, and a puppy again. And this is called, I've got an incorrect header here, but it's instance segmentation. So for the classes that, for the objects that are detected, we can also cut them out by using some sort of masks that are applied within instance segmentation. So you can really cut that out, cut the objects out, instead of just a bounding box. So when we talk about the architecture here, is that, like we said, we want this API to be very easy to be implemented. So the apps or the libraries that are going to be using our API are talking most likely via our public API. So the public API are a visual recognition task related. So they'll be using the visual recognition layer. And then that visual recognition layer, we got the generic machine learning layer, which already mentioned that that's just necessary to implement. That also allows um, machine learning engines to implement our APIs much better by using our interfaces or classes. And the way they're doing that is we got a service provider interface that um, has certain methods and that's able to provide a certain implementation. So when we ask for let's say an image classifier, for we want to do the image classification task, there could be multiple implementations within the machine learning engine, and they are based on input. They are able to provide an instance, a class instance of uh, of the necessary implementation. And fun fact is even that you can use multiple implementations at once. So already mentioned the reference implementation. So that's the default implementation, the basic implementation. We are using DeepNets. DeepNets is a DeepNets community edition to be exact. This is a Java-based deep learning library. Also, the owner of DeepNets is a part of the is one of the spec leads of this JSR. So we finally want to see some action, right? To get a better understanding why we are building this model, is we want to know the process of building a new model. So at first, which is not drawn in this diagram, we first want to state and define the actual problem. Machine learning is really nice and great to be using. It's really fun building a machine learning model, but is it really useful? Could be there. 9 of the 10 cases, there are much more simplistic answers and solutions to be used than machine learning. Machine learning can be really, really tough at sometimes, especially when you have bad training data or no training data at all. Then building a model is not that really sufficient. But let's say that we do have a certain problem that can only be solved by machine learning up until now. So we continue by assembling the training data. So the training data is assembling the trainer data is really the hardest task that you must do, because when you put in garbage as training data, you get also garbage out. So the training data is should be really of high quality, and you should probably also have a massive amount of quantity to start creating a good model. For proof of concepts, you can use obviously fewer data than you would for a production machine learning model. But that's really that's always the hardest task to assemble that data. And for our demo, I've used 60 images of each classes. I've got two classes, which I will explain next. But I've got 60 images. They also they also have to be somewhat equivalent, and the backgrounds are also have also to be quite similar, which is also something important for machine learning models that aren't don't have that much of a training data set. So once you have assembled the training data for the first time, um, you're gonna create an algorithm. And for the GSR, we decided that neural networks are really common to use across many implemented machine learning engines. So if we wanted to cover most of the implementations, neural networks was pretty much the way to go. So we defined that already. And then you have to define the architecture of that neural network. But that's something that you don't have to be focusing 100% on. For especially for proof of concepts, you can just pick one with just a few layers, not 32, for example. It would take a very long time. So the more training data you have, and the bigger your architecture is of the neural network, the longer it's gonna take before it's gonna build the model. And um, yeah, so once we define that architecture, we're gonna build the model, and we're gonna wait. Sometimes models can take weeks, months, maybe, I don't know, depending on the hardware that you have, and the amount. Like I mentioned, the bigger the architecture and the more training data that you have. And then you're gonna perform some evaluations to see how it performs. And then the feedback, you're gonna add that. You're gonna make slight modifications to the algorithm, maybe. But obviously, you're gonna be making a lot of modifications to your training data. So for the demo, um, we're gonna create a binary class image classifier, and it's all publicly available on GitHub. Um, so what we're gonna do is we're gonna classify the input either as a Millennium Falcon or TIE Fighter. So that's slightly different than cat or dog or any other example that there is for classification. Like I mentioned, I've got 60 images of both classes. Um, so yeah, it wasn't the images quality is not that great, but it's sufficient enough to able to classify the input properly. So when we're talking about code, this is pretty much it. This is all you have to do in terms of code in order to create your model. So we're gonna start creating. We're gonna use the neural net image classifier, which is an interface and has a builder. We're gonna instantiate a new builder for it, and gonna say input class buffered image. And for each implementation, the buffered image as input is mandatory. Certain implementation can support different types of input, but the ones that we definitely wanted to support for all implementation was the buffered image, which is also a part of Java, obviously. So the input that we always give to the image classifier is going to be a buffered image. So next will be image height and image width. This also is linked to the input. So Some implementations are able to normalize the input data, and by normalization I mean it could be grayscaling the image because it doesn't understand colors, for example, or it could be scaling to these dimensions. So, for example, if the input is 150 by 150 pixels, it's gonna scale down to 50 pixels. So that's what it could do, or it could throw an exception if it doesn't do normalization and these properties are required. Next will be the labels file and the trainings file. So the labels file contains the different classes that you have and the names of them. And the training file is basically a mapping between the data that you have and the classes. So for example, image one belongs should be classified as a TIE fighter. And that would look like this. So on the left side, we've got the labels file. We got two labels, Millennium Falcon and the TIE Fighter. On the right side, we got the mapping between the image that we have. So we got five images here, as shown in the example. And three of them are classified as Millennium Falcon. The others are TIE Fighters. So that's used in the learning process of building the model. Next will be the architecture. So like we give that as well. Um, from what I know is that the reference implementation requires an network architecture, and AWS Labs um, don't demand a network architecture. They do that for you. So they define one for you. But we are using DeepNets for this demo, so we're gonna be defining that as well. So on the right side, we got the architecture overall in visualized, and we don't have to care about whatever is in between. We now only have to look at the input layer and the output layer, which is also defined here in JSON. So this is the actual file, and it's going to start with the layers input and always ends with output. And for us, what is really important is that the width and the height is equivalent to the width and the height that we give it as parameters to the builder. And then the output is going to be the number of classes. So the width of the output layer is going to be, for us, it's just two because we got a TIE fighter and a Millennium Falcon. So if we got another aircraft or vehicle that we want to add, we're gonna increase that number to three. So next would be exporting the model. So obviously you don't want to train the model over and over again if you want to use the model as classification task. Obviously you want to store that away. So that's what this parameter is all about. And then we come across the last three. So these are pretty much the training parameters. Um, the top two, max error, max epochs, define when we stop training the model. So if the error rate hits below 0.03, we're gonna stop training. The same goes for epochs. Epochs is pretty much equivalent to iterations. So once it passed 100 iterations, which in terms is normally very low, but for our use case is sufficient enough, we're gonna stop training that model. And also this value 0.03, gonna show you in a bit an example. And then as last, we got the learning rate. So the learning rate is a defining factor on how fast you want to go with the training. So if you've got a low learning rate, it's gonna take much longer to train the model, but the accuracy could be much higher when you speed up the process. And all these variables are not really there are guidelines for it. Want to set, but it's just a matter of experimenting and playing around with it. So, and that's also the reason why I found these values uh, convenient at low training time, and the accuracy wasn't affected by the lower amount of training time. And that's basically what you aim for. And then we built the classifier. So this is for deep nets. The output could be similar to this. And what I wanted to point out was the epoch. So here we got the iterations. Um, yeah, I skipped a lot of iterations because yeah, I just have to show you an example. When we look at the bottom two, 30, 33 and 34, it stopped at 20, 24. I mean, 23 and 24. It stopped at 24. So afterwards it completed training, but that's not really the variable that did the trick. It was the training error. So we are talking about max error. Once if you look at the first two iterations, the value is much higher and it declines pretty steeply. When we look at the last two iterations, you can see the difference are very minimal, and they're gonna be slightly decreased by the more iterations that you have. And we set the variable to 0.03, and it obviously hit below that value, so it's gonna stop the training. And eventually, it took 51 seconds to actually train the model. But what's like to use the trained model? So once we've completed, and let's say we're gonna close the Java application, we're gonna create a new one that's gonna run on a Raspberry Pi or something. And we only want what we want to do is we want to import the model and start classifying input. So the only main difference here is that we got an import model functionality that's able to import the model, and that's just it. And then you can use the classify method of the image classifier. And now I want to actually demo that. So I've got a trained model. You can also download it, and you can also train the same model. It's gonna give you the same output as gonna show you now. So what I'm gonna do is I'm gonna spin up a JavaFX application that is able to import a model. So here I have it. I have a small GUI. It's not really that lean, but it works. So what we're gonna do here is we're gonna open a model. Already trained the model. So if you haven't trained the model yourself yet, but still want to use the trained model, it's available within the root deepnet and then trained model dot dnet. Or if you once you've trained it, it will end up in the root of the project as towers.dnet. So I'm gonna open the model. It's gonna load for a bit. Now we know it's loaded, and now it's also available to open an image. So what we're gonna do here is we got test images. So these images should definitely not be included within your training data set. You usually got a test data set and a training data set, and they never should contain each one of another. So we're gonna start with let's go with the Millennium Falcon. So here we got an image. It's quite a light image, 21 kilobytes. Gonna open it up. It's gonna show up within the JavaFX program, and once we hit classify, it's gonna show us results. So here the classification model that we created is saying that the input image is 87%, and that's pretty high. I do know, for instance, that other images which are less of quality. So when we pick this one contains various other accessories on the image, which definitely should not be there, but it's still able to classify that image as a Millennium Falcon, which with not that high of accuracy, but it's still sufficient enough, especially for the demo, to be able to tell that it's a Millennium Falcon. Let's do that also for the TIE Fighter. And yeah, these images are pretty much from Google. So I picked them just from Google. So these are very much different from the data set I have. And I'm also going to show you the images that I have for the data set. And so this one is actually very low, but still sufficient enough. And also to give you, let's say, a 10 second demo, I'm going to show you the images that I have. So here we got an image. It's 21 kilobytes. Gonna open it up. It's gonna show us results. So here the classification model that we to let you know that this one is pretty dark compared to what we use for training. This one is much better and also gives a much higher accuracy. And also came across that the Millennium Falcon is much better classified. It's also probably due to the shape of the aircraft that we use for training. So now that we know that the model is um, sufficient enough, we can then start working on improving the data set. Unfortunately, for Star Wars aircrafts, it was pretty difficult. So once I started working on this model, I also came across when I started adding a third aircraft with also 60 images at the um, the machine learning model wouldn't just train properly anymore. The accuracy would be very bad, and so that's why also the reason when we need much more and much better images than we have now. So it's showing you from a Star Wars movie the aircrafts that are captured. So that's is for the demo. Yeah, thank you for uh, watching the presentation about JSR-381. If you got any feedback or you want to contribute, please do so. The group is down below. So thank you. Are there any questions, Mauro?
Yeah, thank you, Kevin, for this great presentation. Yeah, I got 3 questions actually. So the first one is, how will JSR be distributed? Will it ship as part of JDK, or do we need to download it somewhere?
No, so yeah, we got that question a lot. Um, no, it's not gonna be part of the GDK. We did talk about it, but we first gonna release stuff like you would have to download via dependencies, like Jakarta EE and Java EE, like you used to. So it's not gonna be part of the GDK. So even you can download the dependencies now. They are on Maven Central. So
Cool. Sounds nice. The second question is, how do you actually join a JSR like this? How did you get involved in this project?
yeah, I just started attending the meetings and then yeah, doing small tasks and then grew into it. So I've been doing it for years now.
Was it easy to contribute to it? Like,
Yeah, at first it was especially wasn't really my expertise. It was hard, but they helped me understand machine learning much better, and that allowed me to contribute also via code. So that's pretty cool. So you learn a lot, and learn a lot of new people.
yeah, that sounds sweet. And the last question is, what are the next steps for JSR 381?
Um, so there are missing pieces that we still want to implement, and we still want to ship it with with this GSR, and otherwise we would have to create a new specification request. For example, we primarily focused on image classification, but still want to do the object detection as well. And also what we think is important that we start working on open standards. Um, for example, the models, so that the models that you would create with this engine can also be used, for example, by TensorFlow and Python. We're talking about the Onyx format,
Mhm.
um, stuff like that, video streaming, so that you can that would also be a next GSR to allow video streams to be part of as an input, and also use hardware acceleration. This is also not a part of this GSR, but that's definitely one of the most requested features that we got, is to also use hardware acceleration.
Sounds interesting.
Yep.
There are actually more questions coming up. So
Okay.
let me read for you. One question from Roy Wasse. I think the co-sponsored this JSR partially. So he thinks that AWS co-sponsored it. Is that correct? And are they going to implement this? Do you know that?
Yeah, so AWS already has implemented it,
Mhm.
and they're also part of the expert group. So they also attend our meetings, and also they are even implementing their own sort of API, which allows which require native libraries, for example, TensorFlow and MXNet. That's what they are primarily focusing on, and because they are implementing also our API, that would also expose TensorFlow as one of the implementations to us. So that's one of the greatest contributions that they did for us.
Cool.
And I also got a really cool example, which which is able to classify um, certain certain images whether of lungs whether you have corona or not. So they have some sort of corona classification
Wow.
examples. That's also nice to look at.
The next question is from Wouter Oet. What do you like most about this JSR?
It's really just that simple to use. When I started learning machine learning in Python, I had no idea what I was doing, and the results were just like from the tutorial. I couldn't create my own results. I wasn't at first, and that's what I like about this is just really plain. We've got a very simplistic API. We don't allow that many parameters for customization, and yeah, it's just you create just one object and you can start classifying new input. I think that's one of the one of the things that I like the most.
Sweet. That's it. Besides from a couple of thank yous, and Frank
Thank you.
Greco says excellent presentation. So thanks for the presentation, Kevin.
Thank you.